Questions now. All right. Hey, hi everyone. So this is going to be the KiCAD portion of the workshop, and let me explain to you why we use KiCAD, or at least why I use KiCAD. So when I first started doing PCB design, I was all about Altium until I realized that. Hold on, I'm not on the right phone. Until I realized that once I graduated, I would have to pay about $4,000 a year for Altium access because it's only used for the industry, and generally hobbyists don't get Altium unless they're making bank. KiCAD is free. And also KiCAD is more user-friendly than Altium in my opinion. So I've used both softwares, and KiCAD is open source, so a lot of people can develop new code and new software for KiCAD and make it evolve over time. Currently, we are on KiCAD 7.0. I think like last year we were still on KiCAD 6.0, but as the years go on, they make the UI more user-friendly, they have more features, and generally makes it easier experience for making your PCB. So if you're a hobbyist like me, this is the perfect opportunity to start. So we're going to create a new project. In this case, I'm going to name my basic LED as it's the circuit I created. Just go to File and click on New Project and name your project in whatever folder you want to save this in. All right, that's like the first step. Should be pretty simple. Once you have that finished, we are going to go with the first step of PCB production, which is to make the circuit schematic. So you're going to double click on this schematic icon in the main menu, which is this one down there. And that should open up a page with this sort of dotted structure on it. Sorry about that. Let me just go ahead and pin this. Sorry. Yeah. And for those of you who are joining in from online, if I'm going too fast or too slow, please let me know. I'll look at the chat. So the circuit we're going to be building today is a lot simpler than some of our previous workshops. If you've seen the videos from before, you know that we kind of go overboard on the whole circuit aspect, but today we are going to focus on more of the latter parts of PCB design. So we're going to build a very simple LED button circuit. Yes? Are you recording? I am recording, yes. Thank you. So to place a component, we are going to go to this place menu up here and go to add symbol or add power. The symbols that we're going to use are just buttons, resistors, and capacitors. If it gives you this error, just click OK. That's fine. When you first download KiCAD, you download a whole library of about 20,000 of the most common symbols. If you're using some weird symbols like some op amps or some transistors that don't have a symbol there, you may have to find a symbol from online. And you can find these on online ECAD repositories, or you can ask a librarian, if you're working on this for a company, to make a symbol for you. I've had to make my own symbols before, like on some of these boards. If you see these switches here, these switches aren't actually on KiCAD. These are like not even supposed to be on a PCB. So I had to make this symbol and footprint by hand. And there's a whole art to doing that I'm not going to explain today. But for this workshop, we're only going to use the most common symbols. So we are going to grab ourselves a simple little resistor here. If you just type in the letter R, you should see the item name is R and the description is a resistor. So we are going to click on this and place it onto our workspace. So now we have a resistor in our schematic, right? Pretty simple, huh? We are going to go ahead and click on this component, and because I want to replicate what I had in my tutorial, I'm going to press the button R to rotate, and this will rotate this 90 degrees. Everyone on the same page so far? Yes. So we are going to go to the place menu and go to add symbol, right? And that brings up the menu in which we can get all the other components. So we've got our resistor. Now we're going to get our capacitor. Now for a basic LED circuit, you really don't need a capacitor, but we're just putting it in this tutorial just to show you how to place capacitors on a PCB. That's kind of an important topic that I want to discuss. So we're going to grab an unpolarized capacitor, which is just C, and again, place it on our schematic. How do you open that minus difference? Henry, if you have KiCAD 7.0, you should be able to, you might be on the main menu actually. So if you are on the main menu right here, you should be able to go to File and create a new project. After you create a new project, you should have the files open on the side, and you should have a schematic menu. Make sure to click on the grayish icon and not the greenish icon, because the greenish one will take you into the PCB design software. So once you have these two components on there, we're going to place our next component, which is an LED. And placing an LED is pretty simple. All you got to do is type in LED here, and you will get an item called a light emitting diode. We are going to double click this, and we're going to rotate twice and place it right after our resistor. Now we have 3 components, right? We're getting up there. So the idea is to have this LED be powered by a button, right? So the button we're going to be placing is called a SPST button. So if we type in SPST in the choose symbol menu, this will give us a single pole, single throw switch. SPST just stands that there's 1 input and 1 output, as compared to maybe like an SPDT switch, which has double throw. So we're going to double click on the single pole, single throw switch, and we're going to place it before the resistor. Now, if you have a little OCD like me, you might feel the need to kind of like center all the components together. And realistically, when you're designing more complicated PCBs, you want to make sure that your circuit is very visible, right? So you might be inclined to maybe center everything before, so that you can like look and see what the circuit does. Is everyone on the same page yet? We have 4 components down. Okay, we're gonna put our 5th component down, which is the terminal block. Generally, when you're designing PCBs, you want a way to give your circuit external power, whether that's from a 9-volt battery or from a single cell lithium battery or like a cell battery that is in most toys. You need a way for power to go in the circuit, right? So in this case, we're gonna go to place, we're gonna go to add symbol, and the component I'm placing is called a terminal block. So I'm going to write in terminal, and it's going to show a bunch of different symbols for me to choose from. I'm going to choose a screw terminal 01X02. Now this screw terminal block is this little blue component that's in my PCB right here, right? You can see the batteries, wires are going into the terminal block, and that powers the entire circuit. That's very, very important to have. And for the Zoom viewers, it's this blue component right here. So we're going to double click on this, and we are going to press X. What X does is it flips the component. So let's say I want my power to be in pin 1. And if I just simply rotated it, we can see the pin 1's on the bottom. Now in PCB design, usually if you see a square pad on any PCB, that means it's a pin 1 of that IC or component or chip or whatever. Now you can use your own conventions, but I like to have pin 1 be on the top. At least pin 1 referencing the power or the plus VCC of the circuit. Meanwhile, 2 is going to go to ground. So we have 5 components on our PCB now, which is a pretty simple build. Is anyone lost or needs me to repeat anything? Is everyone good to go? Great, thank you. Okay, so now that we've placed our symbols, we have to place our power. As Vicky said before, nets are the wires that connect components together, and each net is named something different. You can have a 5-volt net, for example, or a ground net, or a net that connects between these switches together, right? So I'm going to go ahead and grab a power symbol, and I'm going to grab the VCC power symbol. VCC stands for voltage common collector. It's generally meant to show the supply voltage of the circuit. So we are going to grab VCC, and because this screw terminal is supposed to be for our external power, we are going to link the VCC to pin 1 of this terminal block. So I'm going to place it right next to it like this. Now we also need a ground for our circuit, right? Because ground is the 0-volt reference point for our circuit. So I'm going to place a ground symbol, and again, I just go to place, and it's now this time it's add power instead of add symbol. I'm going to type in GND. And this ground symbol will give me this triangle looking symbol right here, which represents ground. Now, once you have all the components on your PCB, you can start wiring, right? And when we're wiring, we're creating different wire connections between the different components. So for example, I'm going to connect the wire from pin 1 of my terminal block to the switch, and from the VCC point to this net. Now, this green wire bunch of wires right here is all going to be known as a VCC net. That means wherever we're doing, like later on when I reference this and I say VCC net, that just means like the power, external power is going in through this wire, right? We are also going to connect this switch to the LED, like so. And we're going to connect the LED to ground. what this is going to do is it's going to say, hey, if that switch is closed, if we press on the switch, it's going to connect the external power to the LED and turn on the LED, right? We're also going to place our ground with the terminal block. So the terminal block is connected to the rest of the circuit, right? And finally, we're going to connect this capacitor to the circuit here. Now, normally in this scenario, this capacitor is here to act as a filter, right? It filters out noises or bounces coming from the button. Because when you press and release a button, it's not going to give you a perfectly straight DC signal. What's happening is inside the button, it bounces up and down a few times, which the capacitor can kind of filter that voltage out. You don't really need this for this instance, actually. But again, this capacitor is here to showcase how you can implement capacitors on your PCB. All right. So once you're at this stage, you have your circuit, right? But in order to make this more visible to others, you kind of have to name your components, right? Because let's say this resistor here doesn't actually have a value. If you were at the previous circuit analysis workshop, we went ahead and instructed you to change the value of this resistance, right? And it had an actual effect on the simulation. However, in this situation, if you change the value of this resistor, the user or whoever's putting this PCB together doesn't actually have to follow it. So this can be an abstract value. For example, I'm going to put in 10K for this resistance. My KiCAD is lagging. Oh, here we go. So this will, if double-clicking the R symbol will open up a value field. I'm going to type in 10K for this value, right? From experience, the more you do PCB design, the more you won't have to test circuits before you implement them, right? Whenever you're designing PCB, it's always good to build a physical representation of it on a breadboard, for example, before you build your actual product. Because what's going to happen is if you just design the PCB and you don't know how the circuit works, that's going to be an issue because you just wasted a ton of money building something that doesn't even work. But if you get really good at PCB design, you'll have experience and know how to design a PCB without having to test the entire circuit. Like here, I didn't have to build this out in real life for me to know that it works. So I'm going to change the capacitance to 10 UF. The U here stands for micro. So this is 10 to the power of negative 10 times 10 to the power of negative 6 farads. I'm going to double click the LED and also change this to green. Remember that this doesn't actually have an effect on what comes out of the circuit. It's just there for reference. I'm also going to change this symbol or this text to VIN because I'm going to specify that this terminal block is the input voltage of the circuit. So for example, I can connect a 9-volt battery to the circuit or an 18650 battery, for example, or a AA or a AAA or whatever. It's just the place that the power goes into the circuit. All right. Is everyone caught up to this point yet? Do I need to go over anything before we move on? No? Yes?
I was wondering for the variable names, if you do like a global variable to like change a bunch of names at once?
I don't think so. I could be wrong, but I don't think you can have like parametric things, for example. You've got to do each one individually, and no two can be the same because then let's say you have 2 resistors, you would need those resistors to be like different. But for example, you can have 2 10K resistors, but one's just going to be referenced as R1 and the other is referenced as R2, right? So again, those that 10K label is just for reference. Yeah.
I think there actually is a way to do that.
There is?
At least in my version, there's going to make the annotate schematic. It will do the entire thing.
Right, but annotate schematic is for like R1, R2, the C1, those labels. So this one is actually called a reference field. When you generate a bill of materials for your PCB, that's what's going to say that's resistor 1 or that's resistor 2.
I see.
Resistor 1 and resistor 2 can be the same thing, like 10K, which is the value field, but they can't be the same reference field. I have a question on Zoom. How can I open the blank board like you did because mine is white and different? If you just downloaded KiCAD, yours may be completely white because I have a texture pack basically that makes it black and nice. But if yours is white, that's okay because all of the functionality should still be the same. All you've got to do is go to place, add symbol, and recreate the circuit schematic. All right, any other questions? So we've gone through step 1 of circuit design. Let's go from the beginning. Say you have a project in mind that you want to create a PCB for. You test the circuit in a simulation. You test the circuit in real life. Everything works great. And now you want to make it smaller. So you design a PCB. You completed step 1, which is making the circuit. Now we're moving on to step 2. In Licky's lecture, remember that these circuit things are called symbols. And each symbol has to be mapped to a 2D representation of itself known as a footprint. So the second step in PCB design is assigning footprints. If we hit this button right here, which is the Run Footprint Assignment tool, it's a bit small on the top there. If we click on this, it's going to load up this library in which this is what connects the symbols and the footprints together, right? And so we have 5 things to label, right? In this case, we have C1, which is a 10 microfarad capacitor. Now, if you have no idea what the footprint looks like of your object, you can go ahead and measure a capacitor or test it out or figure out exactly what size it is, because that's what's going to be physically located on the PCB. So to help you with that, there's a lot of footprint libraries. Again, KiCAD, the great thing about KiCAD compared to Altium is that there's a lot of default libraries already ready for you to start making your PCB, right? You don't have to go and find random components online. So for a capacitor, I'm going to go with a capacitor underscore THT. Now the THT, remember, it stands for through hole component, right? So this capacitor is going to look like something on one of these boards you've seen, right? A capacitor goes all the way through the board. Now, because I already have experience and I know what I'm doing, I'm just going to create or figure out a capacitor that is the right size. Now, capacitor axial, if you don't know what the right size is, you can click on this button, which shows you what the footprint actually looks like of this component. So for example, if I had axial here, then this component is horizontal. And you're supposed to put a capacitor across those 2 lines. And that's not what we really want. So we can go down and look at more. Alternatively, you can also figure out a footprint by just looking it up. So for example, if we want a, let's say we want an axial capacitor, but with a set length, width, and height, then we can already punch that in automatically. Or we can look at a disk capacitor or a radial capacitor or rectangular. There's a lot of them because these are the most common components, right? So I don't actually have the right measurements here. So what I'm going to do is I'm going to look at my past projects. The more projects you have in your arsenal, the easier it is for you to figure out, what size of the components it is. This is Blinky Learner 3, that big circular thing you saw there. And this one actually has a bunch of capacitors. If I look into my past projects and I see that, hey, the capacitor I used is called a radial, and the dimensions are 4 millimeters by 7 millimeters by 1.5 millimeters, I can just directly take that and use it for my new project. So I'm going to go back to my other project here, and I'm going to search up D4.0 mm, and I can see that the capacitor I need is right there. And if I click on it, that is a capacitor symbol that looks really like what we want, right? So I'm going to go ahead and double click on this to secure it. Oh, actually, it's a 7 millimeter. So the first component is a radial capacitor with the dimensions 4 millimeters by 7 millimeters by 1.5 millimeters. Double clicking it, and it turns from yellow to white, basically saying that that's the component I need. All right. So the next component I need is a LED. And I can easily go and find what the LED I need is by going to LED here, LED underscore THT. And there's a bunch of these here. But for my other projects, I can see that I use a LED with a diameter of 5 millimeters. So I'm going to type in D5.0 millimeters here and automatically put that into my system. Now, the next component I need is J1. And typically, J indicates a big component or a big power component or terminal block component. So I'm going to go ahead and see what I used from my previous project. And it seems like my J components here. I use terminal block Bornier 2 underscore P 5.08 millimeters. P here stands for pitch, so it's the distance between the pins for the components. So to find this, I can go to terminal block here, and I can figure out what it is by typing in P 5.08 millimeters. Right, and I can see here that I can see Bornier 2 is a 2-pin terminal block, and if I want higher amounts of terminal blocks, it just goes 2, 3, 4, 5, 6. So I'm going to double click on 2 and put that into the PCB design. Now for a resistor. Now resistors can come in many different shapes and sizes. If you understand what power rating is for resistors, say you have a 1/4 watt resistor, it's a different size than a 1/2 watt resistor. So the amount of current you can pass through a resistor determines its size. For this project, I'm going to use a 1/4 watt resistor, and you can see here that I use a lot of axial resistors with this specific dimension. So I'm going to go to the resistor in the assigned footprints library, resistor THT, and I'm going to type in L 3.6 millimeters underscore D 1.6 millimeters, and I can see that I have a bunch of options here I can choose from. I'm going to want the biggest one, which is the pitch being 7.62 millimeters. I'm going to double click that and it's going to put itself into my library. Now the final object I need is a button. And for the button, I can just look and see what I used before, which is a button switch. So the button switch object, which is button switch THT, will have all the buttons I need for my footprints. And in this case, I'm going to use a 6 millimeter by H 4.3 millimeter. Now I know that was a little bit fast, so I'm going to take some time here. I'm going to close out of my old library or old project here, and I'm going to expand this just so you can go ahead and was this open? You can go ahead and find all those objects in your library. You can also make custom libraries. Like here I have one I did for last semester's PCB design workshop, but you can also just search up these items on the toolbar up here. I don't think I can zoom in, I apologize. So I'm gonna give you about 2 to 3 minutes to do this, and then we're gonna move on. Again, this is step 2, which is footprint assignment in PCB design. All right, thank you, Henry. Yeah. I can't zoom in, I apologize. You can come up and take a picture if that would help. Not actually sure how to zoom in.
Or just copy and paste the order.
Oh, I can, oh, hold on, I know what to do. Is my computer slowing down? Yes. Yeah. Hello? It's not letting me see the screenshot. All right, that might be better. All right, does anyone need more time? Okay, a few more minutes. All right, ready to move on? Anyone need more time? No? Okay, we're moving on to step 3 of PCB design, in which I like to call, this is the fun part actually, because actually this is not the fun part yet. Fun part's routing, because then you got to do all these like artistic design. It's like playing Flow. Does anyone know what the game Flow is? Yes. Yeah, so PCB design is basically playing the game Flow. There's like only one person here that knows. 2.
I would know. I'm just
3.
what's flow.
So okay, let me see if I can Google this real quick.
I might have heard, but I don't know. I know a lot of games.
We're gonna deviate from here a little bit. Flow game. So it's this thing. They give you a bunch of colors and it's a puzzle game, so you gotta like connect from one dot to another. And it's kind of like PCB design because you can't. There's a rule in here where you can't like cross the line. And in PCBs, if you're designing on like one layer, you can't cross lines. Yes.
I've played this before. A long time.
Yeah. So it's basically a game. So now that we have footprint designs, what we're going to do is we're going to map these. Uh-oh. Oh, crap. Oh, I made it whoopsie.
Did I ruin your flow?
Yeah. Okay, hold on. I have to do this again really quickly. It's a good thing I took a screenshot of it. D 4.0 millimeters. Axial. I think it's this one. And then diode, 5 millimeters. This one, terminal block, Ornier. 2 resistor. D1 L 3.6 millimeters. This one, SPST, button switch, 6 millimeters. Button switch, 6 millimeters. THT, SW push, button switch, THT. Okay, we're gonna click apply, save schematic, and continue, and press OK. All right, what we gotta do next is we gotta enter the other file that we saw in the main menu by pressing F8. And once you press F8, it'll like lag a little bit because it has to process everything. And then it's gonna open up the PCB design menu, which is this. We're gonna press on update PCB, and that will put all of our components onto the PCB designer. Now, there's a few things of terminology I'm going to go over right now that we are going to cover before going to the PCB design because it's important. First of all, the grid. Now, this grid is going to snap your components to a certain sensitivity. If you want a more sensitive arrangement procedure, you're going to go with a lower grid size. If you want a more like visible exact grid size, you go with a higher one. Now, personally, I like to start with a 0.0250 inch, or this is also known as a 250 mil, actually this is 25 mil. Yeah, so 25 mil grid size, and you can see that this is a little bit, if you move one of the pieces around, it's gonna be very sensitive, right? If you go for a 250 mil grid size, it's going to be a lot less sensitive and a lot more blocky. So when you start arranging the components, generally I like to start with a big grid size and then move downwards for a lot of the smaller components. This is just a sort of easy way to sort things out. Just to not confuse yourself later on. If you want to change your units that you use for KiCAD, go on the sidebar and you can have inches, mils, and MMs. Now, this is really confusing for a lot of people because the first time you see mils is probably in PCB design. Mils, or MILS, is a unit of measurement that's 1/1000th of an inch. It is not millimeters, and it confuses a lot of people. So be careful. If you want to use millimeters, that's generally for like, it's easier for production if you're ordering PCBs from China. But if you use mils, it's easier for us because we are in America and everyone here uses imperial units for some reason. So I like to keep using mils. Now I'm going to put my grid size to 50 mils just because it's not too sensitive and it's not too easy. Yes.
Can you show me how to get it?
Yes. So you get to this one. Oh, press F8. Yes, press F8 and then press update PCB. So alternatively, you can use this button that swaps between the two views. Right, it's up here. There's a symbol here, open PCB and board editor, and you can open the schematic as well. But F8 is what updates the components because these two documents have to be the exact same. If they're different in one way or another, you're going to go into issues when you run your DRC or when you run your electrical checks, right? So I'm going to use a grid size of 50 mils. Personally, this is a Goldilocks grid size. It's not too sensitive. It's not too weird. I don't know what the opposite of sensitive is. So generally, a good practice to start placing PCBs is to go with the flow. Basically, go with what your circuit looked like. A lot of times this is not going to be the case, but if you can match the two, it'll be easier to put the components on the board. How can you use mils minus inch? So to convert units, you will go into PCB view. On the left sidebar, you will see a bunch of conversion units on the top. You can see inches, you can see mils, millimeters, and those three you can just swap between the units. So if you're in inches like this, you can just click on mil and you can go into mils measurements. So I'm going to go ahead and rotate this component, and rotating is the exact same as before. Just press R. And I am going to place my components like I did on my circuit. So something along the lines of this. Now you can see the rat's nest here, and the rat's nest is just these lines that connect the electrical components together. Another good rule of PCB design is you want to try to get the smallest PCB possible. You don't want to waste any space. Now that's hypercritical of me to say because a lot of Blinky learners actually do waste space, but that's different. If you want a functional PCB to use in your robot, you want to make sure you have the smallest amount of space possible while giving each component room to breathe. Because if you put each component too close to each other, what can happen is when they're manufacturing, the components will short each other out. So there's a manufacturing error. So always Goldilocks zone, make sure each component has enough room to breathe. So for example, I'm going to go ahead and place my resistor here vertically so that I can place it right next to this switch, right? And then I'm going to put my LED right next to the right next to the resistor as well. Now this capacitor here, generally you want to put the capacitor as close as possible to where it is used. Yes? Sure, let me check it real quick. But generally, you want your capacitor to be as close as possible to wherever it is used, because the further away it is, it creates like redundant resistance. So you don't want that happening to your circuit a lot. Okay, so I think you spoke to 1 or 6, which is a 6. Go ahead and you can just like place it in sort of that orientation. You should be able to click it and go. There you go. Okay. So the reason why I put a capacitor on the circuit is to, like at least introduce you to some good PCB design practices. Again, for filters, you want to put them as close as possible to where they are used. For example, in this case, this capacitor right here is placed right after the SPST switch and right before the R1 resistor. So it'd be pretty dumb of me to place it like all the way over here or all the way over here, right? Because you don't want your PCB to be like gigantic. So what I am going to do is I'm going to go ahead and place this capacitor actually right before this LED. And I'm going to put the capacitor like that. Now there's probably a better way to make this PCB a lot smaller, probably like this actually, because if we can see here, this capacitor just connects to this net right here. So the trace, if we connect a wire between this point and this point, it's going to be very, very short. All right, and then we can drag this whole shenanigans over here, right next to the button. So now we have we have all the components placed, but it looks very messy because all the labels are all over the place. And this is just a tip from me, just because I hate having messes on my PCBs. I like to go ahead and just, for these grayed out labels, I like to just make them invisible for now. This way I can focus on the labels that are actually visible, and then I can place them to wherever I need them to be. So I spent some time here just getting rid of these. So there are different layers to PCB design. You can see the different layers on the right-hand side here. And there's like front copper layers, back copper layers, front silk screen, back silk screen. These gray layers aren't actually going to be on the PCB. They're just there for reference. So when you actually produce the PCB, any gray layers, actually this is on the F-fab layer. This one can actually get produced. But any of the yellow layers you see, like the D1 here, the switch 1 here, these are actually on this front silk screen of this PCB. And the silk screen is kind of like the white stuff you see that labels all of the components on the PCB design here, right? It's also what creates that logo, if you want to put a logo on there. All right, so what I'm going to do is, now that I've gotten rid of the unnecessary gray labels, I'm going to go ahead and rotate these labels to put them as close to the component as possible. So for example, D1, C1, switch 1, R1, like that. And if let's say R1 is a little bit too big, because the distance between this distance right here between R1 and the left side of this resistor is too small. If you're manufacturing this in JLC PCB or Osh Park in America, they might have a limitation as how sensitive or how close these two silk screens can get. So I'm going to go ahead and make this a little smaller. I can do this by double clicking R1 and just changing the value of this right here. I'm going to change it to 25 mils. And I'm going to change this to about 4. So that makes it a little bit smaller. And now I can go ahead and just get rid of this real quick. Drag this J1 label up here. There we go. Okay, so now in this very simple PCB, we have specified what each of the part components are named. I'm actually going to go ahead and drag this down here just to make it a little simpler. Like that. I can go ahead and put this over here. Again, what I'm doing is just making so the readability of this PCB is a lot easier. So when someone is assembling this PCB together, they can go, hey, I know what J1 is. It's terminal block. I can just put it right there. So what we're going to do next is we are going to define the outline of the PCB, right? Like what the shape of the PCB is. And we can do that by clicking on the edge cuts of our PCB here. There's a little item here called edge cuts, and that defines the outer border of the PCB. We're going to create a grid size of 25 mils, grab the line option from the right sidebar, and we are going to draw a box around our PCB. Like so. If you want to get fancy, you can also make curves. I like putting curves on my PCBs just because, you know, it's a lot harder to stab yourself with a PCB if it's a rounded edge. But you can make curves like arcs, but for this tutorial, we're just going to stick with a basic rectangular shape. You will know this works if you go and press Alt-3 and you enter the 3D view, and it shows you your PCB with just like, you know, the components and the border like so, right? So we know that our edge has been defined on this PCB. I'm actually going to lower this bottom edge a little bit just to give that capacitor more space. And I'm going to center everything. Half of PCB design is also an art. You want to kind of make your PCB as visually appealing as possible so that if you're designing this for a client, they'll like it more. I've definitely been in situations where being overly cautious about the artistic aspects of a PCB has helped me. Yes?
So does the artistic, is what you're talking about, is that specifically the component placement, or is it the copper wires?
Oh, it's everything. Like you can have artistic designs for this, you can have neat designs for wiring. Almost everything after the circuit schematic part is an art.
Okay.
The more you do it, the more you'll get better at it. But the fun thing about PCB design is that, hey, I'm terrible at art, right? But I love PCB design because it's functional. I can see it out the other side. So, you know, don't ask me to paint something for you, but I like that.
Okay, cool. I wasn't sure if it was good or bad.
Yeah. I have questions. If I made a label invisible, how do I get it back again? Good question. You can probably get it back by deleting the item and then pressing F8 to update the PCB again. That spawns in the new elements because the schematic and the PCB is always linked together. So you would just, you know, respawn the thing back in. And how do you create a whole line cover all of the stuff? On the right sidebar, there is a line tool that you can use to draw lines. Before that, you must select the edge cuts layer because you have to select which layer you're putting the line on. So all the right sidebar items are here. So you go to edge cuts, you press the line, and then you draw a line around the entire PCB. All right. So once you have finished edge cuts, again, you can press Alt-3. Alt-3 is the command to see a 3D representation of your PCB. The cool part about this is you can also make a rendering. And you can use ray tracing here. There's a button on top to make a really nice view of your PCB. And it just generates it all. It's pretty cool. There's shadows and everything. It's awesome. All right. I'm going to give you guys a few minutes to get to this point. And then we're going to continue on from there. So while you guys are getting to this stage, I'm also going to add some textual elements onto the PCB. Half of this is making sure the user doesn't come back and complain at you when they're using it. So especially for things like BlinkyLearn or for our soldering workshops where maybe less experienced soldering students would put it together, I need to make sure that we have a lot of labels on the PCB telling you how to put the components in. Things like capacitors, things like diodes, they may be polarized, so they only go in one specific direction. things like the power input, that has to go in through one direction. So we are going to go ahead and just create some text here. I like just creating a, go ahead and do place text, Control-Shift-T, and then making a plus symbol, maybe making this a little smaller to put next to my VCC and ground. And I want to make sure that this label is actually on my silk screen, right? So in this layer here, this will be on front silk screen. And I'm also going to just copy and paste this and put it as minus, because I want to make sure that they know that this is ground. Also on my front silk screen. So if you don't select the layers on the right, it won't actually place it in the right layer. So you might have to do this yourself. All right, there you go. And you know, this isn't aligned correctly, but you can like spend more time just making sure that everything is aligned properly. I've spent so much time on my own just making sure that things are centered and whatnot. It's an art. I have a question. How can I see my PCB, Henry? It's Alt-3. Once you're in this view, press Alt-3, and you should be able to see your PCB in 3D. So for every like polarized element on my PCB, I'm just gonna go ahead and place a component there. Yeah, that should be good. So for example, my diode also needs a plus and minus. In this case, it looks like my diode is a little bit backwards, so I'm gonna flip it. The reason why I'm doing this again is because I want my traces to be as short as possible. So going from this 2 to this 2 is shorter than going from this 2 to this 1. Can you try to do the edge cuts thing again? Sure. So to make an edge cuts, you're going to go to your edge cuts layer on the right of your screen where it says edge cuts. Then you're going to make a line and you're just going to create a box around your PCB. Like that, around your components. And it should be gray colored, or if you have a different KiCAD theme, it can be like orange color or yellow colored as well. It's just that you want to make sure that all of this is in the layer called edge cuts. So I'm going to go ahead and put a plus on top of my diode right here, or maybe like right here. Yes. So go ahead and press Control-Shift-T, or you can go to place and add text. And for the text, you can just put plus symbol here, and then make sure the layer is on your front silk screen. I changed my size of the text to 25, 4 mils, and then I can change my position to center it. When I press OK, it then spawns a plus symbol that I can just place down. What's up, Chase?
Well, I was going to ask, if you have a schematic that you go flip and it flips the text on the schematic, are you able to just flip the text back without flipping the schematic?
The schematic?
For example, like right here, I have the Arduino. I flipped it and flipped the text here.
Yeah, when you flip that text, it goes to the other side of the PCB.
Oh. Yeah.
So you can't actually flip it on along the x-axis. It goes to the other side of the PCB, and it gets put on the. So it might be a different color. That's why.
Okay. Oh, okay. I thought it was good. That's good to know. That's where I was going to.
Yeah. Happens. All right. So for this capacitor, I'm going to put it right here, and right here. There we go. So that way, people know that when I make this PCB, I'm going to put my red wire in that plus symbol and the black wire in the ground symbol, and there's no way that they'll mess this up. That was sarcasm. They're obviously going to mess this up, which is why when you design your circuit, you want to make sure you have like reverse polarity protection or something like that. Learn that lesson the hard way. You guys need more time? Yes? Okay, a few more minutes. Can you show us the details of the plus sign again? Sure. So for this plus sign, you know, I did this really fast just because I have a lot of experience, but you know, finding the right size and options for this does take some time. So I put it on the front silk screen. My size is 25, 4. This is something I find just like by doing a lot of PCB design that works for me. and then I put it in the center, and then the position doesn't really matter because you're gonna reposition it anyways.
Can you remove the text box?
Oh, yes. What I like to do actually is instead of putting R1 in here, I like to make this invisible and then put a indicator that this is 10K, 10K as well. This is important just because if you're assembling this PCB by hand, you'll know that it's 10K rather than having to like reference some sort of like BOM. And for the capacitor, it's 10 UF as well. So something like this really helps. Of course, if you're getting something called a PCBA, which is a PCB assembly, you won't have to do this. But because this is a pretty simple PCB and most likely you can assemble this by hand, you would go ahead and do this instead. All right, anyone need more time? Can we move on? All right, just to recap, this was step 3 of PCB design, right? Step 1 was circuit schematic. Step 2 was assigning footprints. Step 3 was placement and labeling. Step 4 is routing. This is the fun part because then you get to get rid of all those nasty blue rat's nests by connecting wires to all the components. So this is the simple version of PCB design. So I'm not going to get into polygon pores. I'm not going to get into vias. That's for the more advanced stuff. But right now, all we're concerned about is connecting all of these components together. So we're going to grab the line tool and we're going to go on the front copper layer. This is, for me, it's red, but for you, it can be like green, orange, blue, like whatever theme you choose. Yes?
And standard PCB design is 2 layers.
Yes, standard is 2 layers, which means you can have a top layer and a bottom layer to connect things together. I'll show you both in this example. I'll use the top layer for VCC and I'll use the bottom layer for ground. So in this example, what I'm going to do is I'm going to connect, basically I'm going to choose my grid size first because again, remember, like the higher grid size, the more it's going to snap. So I'm going to choose 25 mils, and the lower it's going to be more sensitive. So to make it neat, I'm just going to grab the, not the line tool. So the wire tool is actually this one right here, which is X. So my shortcut is I press X, and suddenly I can drag the wire from one component to the other, right? That's just a shortcut you can use. I'm going to do something like this because then it's going to snap at me. And what I want to do is I want to just connect all of these components together. So obviously with a simpler PCB, it's going to be easier to know how to, connect this. But with a harder PCB, that might be a little more complicated.
Show mine if you want.
I can show yours, yes. I can also show you some of my own more complicated PCBs. Yeah. Okay, so this process, routing, takes a really long time if you have a really complicated PCB. If you're working with like an Arduino chip and you're trying to build your own Arduino, and that little chip has a bunch of pins you got to connect everywhere, then you got to start worrying about like what layers you got to put things on, and stuff gets wild fast. So here I'm going to use my blue copper layer just to show you that you can put stuff on the back too, to connect all the ground components together. Like that, and like that. Generally, what I would do for a more advanced PCB is I would use a polygon pore for both the VCC on the front and blue on the back, just because it reduces the amount of wires that we're using, and the polygon pore can allow you to pass more current through the entire PCB. So in this case, your default route width, right, really matters, because if you have a thicker route width, you can pass more current through. And there's actually a whole table that shows you what you can and cannot do. For example, 10 mils allows you to pass around 1 amp through the circuit without things catching on fire. You know, for this circuit, because I know that I'm not going to pass more than 1 amp of current through this circuit, I don't have to use thicker traces, right? But you know, if you're making a PCB for driving motors, for example, you're going to need larger traces because motors will pull a lot of current through the PCB, right? So in this scenario, what's going to happen with this manufacturer is that they're going to put the red traces on the front of the PCB and the blue traces on the back of the PCB. So what happens when I press Alt-3 is that you can see that, right? The traces we had in red are visible on the front side of the PCB, and the traces we did on the back are visible on the back of the PCB, all right? You know, routing shouldn't take you that long. So once you have this done, you're pretty much done with the PCB. All the components are connected. You can go ahead and order this on GLC PCB, and you can just, you know, get your PCB in like 1 or 2 weeks, depending on how much you pay for shipping. So before you end your PCB journey, you have to run a DRC, and this is a must, right? Because if you don't run this, and the DRC checks to make sure your PCB is okay for ordering, if you have any mistakes like unconnected traces, it'll yell at you and tell you to fix it. If you don't run this and you accidentally order a PCB that has a mistake in it, that's 2 weeks of time lost. That's about $100 lost. And you will basically have to start over from scratch and reorder it, and there's more time wasted. You know, time is money, and if you're spending money on time, it's like money squared. Talking from experience here, it's happened to me before. So be careful. To run a DRC, you go to Inspect, and you go to Design Rules Checker. You press Run DRC, and it will tell you if you have any warnings or any errors. Now, warnings are okay. Like I get warnings for my silk screen being too small or things not being right. If it's a silk screen warning, you can just ignore it, right? But if you see an error and that error goes above 0, you kind of have to pay attention to it because that's telling you that your PCB might not manufacture correctly if you have an error, right? Also, what you want to check is unconnected items and schematic parity, because I'm going to click test for parity between PCB and schematic. Because if you have errors in unconnected items and schematic parity, that just means that something isn't connected on your PCB. And that's very, very bad because you want to base your circuit off what you made in the schematic. Theoretically, that should be your ideal version of the circuit, right? So I have no errors here. My life is great. I can just go ahead and click close. So at this point, your circuit is ready for production. So if you wanted to do things like add curves, add arcs, add mounting holes, you can do so. I'm actually going to teach you how to add mounting holes because I think it's a very important part of project development. You want to make sure that your PCB has some way of attaching itself to whatever robot you make, right, or whatever project you make. So go ahead and go to the edge cuts layer. Actually, before I do this, let me check on questions. How do I create the ground line? So you can go ahead and click on back copper layer, BCU here, and just click on X again and start making the lines. And this will allow you to make lines on the back side of the PCB. But do note that your ground lines can also be on the front copper layer of your PCB as well. I just showed you this because I'm just showing you can do it on both sides. So I'm going to go to edge cuts and make a circle. And this circle, I'm just going to place the circle on a, maybe like right here on my PCB. Now, depending on what kind of screw you use, you're going to need to like make sure you have the right screw hole size. In this case, this screw hole is 50 mils in diameter, which is good for anywhere between a M2 screw to an M3 screw. I believe that's your options there. I think M3 might be a little bit too big, but I usually use a 50 mil diameter screw for M2.5 by 6 millimeter holes. Again, this is just from experience. So the more you do PCB design, the more you can remember what standards you use, and then you'll be able to like do projects a lot easier. So for example, I'm going to put one mounting hole here and one mounting hole on the bottom. That way, when I make this PCB, what I can do is I can use some screws to screw this PCB onto something else, right? If you've ever seen an Arduino, you'll see that Arduinos have holes inside the PCB that way you can mount it onto a robot, right? Again, you can also add stuff like arcs. I'm not going to go into making arcs here because that might be a little bit too complicated. But for example, you can do something like this, and then you can drag this back. And this basically makes you a arc. So when you look at your design, now your board is curved. And again, I like doing this because I'm a very clumsy person and I like stabbing myself with PCBs, and they hurt. So I generally do this to make sure that, you know, like you can't hurt yourself with the PCB. And also makes it look visually nicer. So again, I'm doing a lot of like optional cleanup stuff here. You don't have to do this. You can just leave it as square and rectangular if you want to. But just generally, this is what I like to do, as sort of making sure that the PCB is nice and finalized. Because again, I mean, PCBs is a pricey hobby. You're spending a lot of money getting one of these boards. You know, I actually wish they did the free PCB ordering this year as well. If some of you were from last year, I used to do this thing where I would order a PCB if you designed it for this workshop, and it'd be free of charge to you, just so you could test it out and see what it looks like. Too bad they're not doing it anymore though. Okay, so I've made my curves on the PCB, and you can see that on my 3D model here. Now we have a nice little PCB with 2 mounting holes and curved sides. And my DRC has passed, my schematic has passed. I am ready to now fabricate this PCB. How do we border it? Can you show again? If you want a border, again, remember this is on the edge cuts layer. So you want to go to the appearance tab, go to edge cuts, and then select your arcs or lines. And this will allow you to draw edge cuts. And for what I did here is I just went ahead and created this arc, and then I took these lines and moved them back, just so that it creates one solid rectangular surface. Because if you don't do that, then it won't know what edge cuts to make, and then your 3D model will look a little bit weird. So your 3D model is a way of testing to make sure that your PCB is ready for ordering. How do you do DRC again? Go to Inspect, go to Design Rules Checker, and go ahead and click Run DRC. Oh, it says I have a error, which is not good. It says I have a circle and edge cuts, which, oh, this is a really good, okay, this is the reason why we do a DRC. Because it's saying here that I have an error because I put a hole directly on top of this trace, which is not good because the hole goes all the way through the PCB. So to correct for this error, I will go ahead and delete this trace and just make my ground trace go around this. Now, generally, you don't want to do this because you want your traces to be as straight as possible, but in this case, it's okay. So if I go ahead and run DRC again, what happens is I fix that error, and now I have 0 errors again. And I can now go ahead and fabricate the PCB. 50 mils. You can also check, by the way, if you click on this ruler symbol down here, and you can check between one hole and another. Actually, the radius is 50 mils. The diameter is 100, which is good that I checked. So you can check using the measure tool. There's a ruler down there, and you can check that the holes are 100 mils in diameter. And again, this is about 0.1 inch or 0.01 inches. All right. Yes. The blue lines and the red lines? They're on different layers of the PCB. So the red ones are on the front, the blue lines are on the back. You can draw them on the front or the back. It doesn't really matter. With more complicated PCBs, you'll find out the only limitation is that you can't cross lines. So for example, if I wanted to make a red line from ground to like over here on the top, I can't pass this red line, right? It forces me around it, right? So that's just the reason why you wanted to use the other layer, is to make sure that everything can connect together without messing up. All right. Anyone need more time? Yes. Yes.
Will the trace width affect Y resistance?
Yes. It will affect resistance. It'll affect a lot of things, but generally the reason you would want to change your trace width is you want to allow more current to pass through that route. So for example, if I wanted to build like a solenoid driver, and by the way, a solenoid is like a piston, like a Minecraft piston. Solenoids use a lot of current. Most of the time there's 3 amps. If I wanted to drive a solenoid using this kind of trace, it wouldn't work because this is 10 mil. 3 amps require a trace width about 50 mils. So I would need to go ahead and change the trace width by going up here, editing the predefined sizes, and that opens up a new menu, and you can change it. I'll actually show you what it looks like because I think it's pretty good to know. So let's say I want 50 mils, right? I will just make that option there, then I can change it. The next time I want to draw a trace from, let's say, ground, track, it'll be this big. Kind of chunky board. But that will allow you to pass 3 amps through the circuit board. And you can actually see it on the 3D viewer as well. It's like massive. Yeah.
Kind of random question.
Mm-hmm.
But is there a market for artistically made PCBs?
There is.
Like ones that look like things?
Yeah. Oh yeah. I've seen PCBs that look like Pikachus, look like stars. Like there's like really intricate edge cuts. I mean, that's the whole idea behind this one, the circular one, right?
Chris, you'll give me a presentation. That's all I'm gonna say.
Hey, I hated art before PCB design. This is like right up my alley.
Well, no, now I have an excuse. I'm like, I'm being productive.
Yeah. Anyone need more time? I'm gonna go over one more thing before we end this workshop. All right, so we've gone over step 1, circuit design. Step 2, assigning footprints. Step 3, placing and labeling. Step 4, circuit routing. Step 5, can anyone guess what it is? Fabricate, yes, to make the PCB come to life. So there are different ways to do this. But the way I like to do this is I like to first create a BOM. This helps the end user or the client, if you're making this for someone else, assemble the PCB on their end. I believe I had a guide on how to install this plugin, but this is my Generate Interactive HTML BOM. If you don't have this button, what you need to do is you need to go back to the main menu, go to your Plugin and Content Manager screen, and go to Interactive HTML BOM, and you want to download or update this. I'm just going to update it till I can. All right, once you do that, and you go back to your, schematic, you can go ahead and click on this button, and it'll create a BOM in your project folder. And it'll look something like this. And I think this is super useful for figuring out, what parts you need for your PCB. Like for example, you can, if you have already the component, you can click on sourced, and if you have already placed the component, you can click on placed. You can print this out too. Yes.
Which menu did you
Plugins, plugin and content manager. Yeah, you can also download Word to PDF. Yeah, that's the cool thing about KiCAD is because they're open source, so people generally make quality of life plugins for you to use, and a lot of these are really useful. It's just I don't use a lot of them. Yeah. Interesting. I'll come take a look. I would say this is got fresh down. You know it's not oh, it's Josh's computer. Don't worry about it. This computer. It just has a case. Don't worry about it. It'll be done on your own computer. It generates a bill of materials. So I'll show you. So again, bill of materials are really useful for figuring out, how to make your PCB come to life. So again, to generate it, all you got to do is you got to go to your schematic here, press this button on the right, and that generates an interactive BOM for you. All right. So what you want to do next is, depending on who makes your PCB, they'll have different instructions on how they want your PCBs to be generated. I like using JLC PCB, but if you want to use something else, you can. But JLC PCB has their own guide on how they want you to produce the gerber and drill files. Because the way companies make this PCB is they need to know exactly how to drill out the holes on your board and also where to place the pads and the routing and everything. So generally there are 2 different files, gerbers and drill files. So this article has a guide on how to do so. And I don't suggest you do this now, or if you want to, you can follow along, of course. But if you're not going to order this PCB, you don't really have to do this. So what they want is, they have a really good guide on how to do this. And I've done this so much that I practically remember how to do this by heart. You go to File, and you go to Fabrication Outputs, and you go to Gerber. That's the first step. All right, what happens next is it requires a lot of weird selections, but generally I think it's wants to use Proton name extensions and subtract solar mech from silkscreen based on its guide. And it wants to check zone fills before filling, which is fine. So generally this is okay. You don't need to change anything here. It doesn't want you to use X2 format, which is fine. How do I know that did my PCB work or not? Henry, if you ran your DRC and it came back with 0 errors, you're good to go. And then you can start ordering your PCB online. So this step, which is step 5, is fabrication. And we're going over how to put your PCB project in a format where your manufacturers or fabricators can understand it and make the PCB for you. So I'm going to go ahead and click plot. And what this does is, oh, I actually messed this up. What I like to do is I like to create a new folder called Gerber. And I want to put everything inside this folder. Because what happens if you accidentally click that button is it puts all of the files on like the main menu, which is terrible. So we're going to go ahead and click this folder, select folder, and yes. You want to use a path relative to it. Click plot, click generate drill files, and click generate drill file. You don't need to change anything here. You also want to generate a map file that goes along with the drill map, and then you can click close. So what happens here is we just generated a bunch of files. A bunch of files here. Just get rid of these. We generate a bunch of files in our Gerber folder that has the instructions needed to make our PCB. So what you need to do from this step is just zip this up. You highlight them all, right click, go to 7-zip or send to zip file. And I like to name this stuff as 5x03 basic LED Gerber. And you would upload this zip file to JLC PCB or any other PCB fabrication service, right? And that's basically it. Then the waiting begins. Long turnover time from when you order it to when you get your PCB. And during that time, it's really stressful because you don't know if your PCB actually works or not, right? But it's very worth it if it does. All right. So again, you don't have to go through this step if you don't want to, but I will have these instructions up for you at the end of the workshop or maybe a few days after the workshop so you can follow it at home. So if you want to do your own projects and make a more complicated PCB, maybe one of those Blinky learners over there or your own robotic controller, then you can go ahead and do these same steps. There will be a lot more components. There may be a more obscure footprints you have to get, but all of the core steps are the same. Just step through it, then run the DRC, make sure it's valid, order your PCB, and then reap your rewards from your projects. All right. Are there any questions? Okay. Yes. Non-KiCAD. And generally, you don't want to auto route. Altium has a cheat code in which it does all this routing for you, but there is an art to routing, like a functional art. And Chase is going to say something about that, but there's a functional art to routing, and auto routers usually don't take into account of that, right? They don't take into account maybe if you're designing something for RF and you need wireless communication, maybe they won't design the RF part exactly how you want it. And maybe they put some routes too close together, maybe it's too far apart. There's a thing in PCB, or at least electricity, where if you have two routes going side by side, they may interfere with each other because current causes magnetic fields to generate. So you want to, as you know, the engineer, you want to be sure of all of these different restrictions and do the routing yourself.
I may hold very close together. Hopefully that doesn't affect.
Can I see?
Yeah.
Yeah, again, you want to make sure the PCB is as small as possible, but give them space.
I did. Yeah, that makes sense.
Space is used a lot of space.
Yes. Leave them.
All right. Let me check for questions. I have just yes. Okay, so I am on the Hyperloop Discord. My name is still like blue, but if you need to reach me, my Discord is locklockfafa, and you can Discord me, message me. If you want, I'm gonna like shamelessly plug myself out there, but if you want PCB orders as a group buy, which means that you don't have to pay like a $40 shipping cost, you can just let me know because I order PCBs like once every 2 weeks, and it can decrease the shipping cost for you if you just want it quickly. I know Hyperloop's not doing their deal anymore with free PCBs, which they should really do, but I'm not in charge of it anymore, so just let me know. And if you have any questions on PCB design, I'm always happy to answer them. Yes? No, it's kind of like just for reference. So after some part of it, it doesn't show up anymore. The ones that really matter are front copper, back copper, front silk screen, back silk screen, and edge cuts. The rest don't really matter. All right. Well, that is all. I'm actually really happy that we got to the finish line for one of these workshops. This is the first time that's ever happened for my 2 years of teaching this workshop. But we've got a completed PCB. Don't worry about the simplicity of the circuit. All right. Thank you guys so much for coming today. Really great seeing you here as always. And I look forward to seeing what you guys make.